Hi everyone, my name is Dipin Upadhyay. I'm a Google Cloud data engineer with cloud consulting company, PSO. So my today's talk is about accelerating CDC data ingestion with Apache Beam. CDC is a technology to get changes in the data in the database, and then how do we transform, how do we put that data in more real time. The agenda of this talk is I'm going to talk about an overview of the solution that I'm going to present. The solution is more specific to Qlik, and if you are already adapting Qlik and Kafka, this is more tailored towards that, assuming that you already have Qlik and Kafka. So we'll outline some of the guiding principles. We'll also talk about the overall architecture we built based on those guiding principles. I'll discuss ingesting CDC to BigQuery. We'll talk about the Qlik data format, how do we handle error, and some observation and optimization that we did in the Dataflow pipeline. So our aim was to build a data platform for CDC changes. The data platform that allows a data producer to define the way they want to represent the data and publish that data. The data platform should be able to ingest different sources, though we are primarily focused on CDC in this particular solution, but it should be able to incorporate all different sources. Downstream customers, either it be a ML engineer, data scientist, or just a business analyst, should be able to fetch out, bend out that data and use it. And we want to build it in a way so that it's decoupled and have a clear operational ownership. To build this data platform solution, we came up, we had a bunch of guiding principles. The guiding principles help us to design and choose the services that we need. A few of them are outlined here. We want to use as many services as possible. We don't want to be responsible for increasing machine or changing machine type. We don't want to write a different Beam pipeline code if a database has been changed or if we are importing something different, a different schema. We want code reusability. We want to write that code and then have enough configuration so that the same code can be deployed multiple times. Data security and data privacy has to be treated like a first-class citizen, and it has to be baked in right from the beginning. We want to make sure that the data is available for business analysts or downstream consumers within seconds. Infrastructure as a code was another guiding principle. Whatever we write, we want to make sure that we are writing it as a code, either Terraform, Pulumi, or other language of your choice, but that was another guiding principle. And finally, we want operational observability. If something happens within that pipeline, and we want to get notified so that a proper action can be taken, right? These were the guiding principle. Based on this guiding principle, we went through some iterations, and we we built our basic architecture. Again, in the beginning, I told that this architecture was mainly designed with Qlik and Kafka in mind, right? These are for the customer who already have Qlik, Replicate, and Kafka, and they want to leverage these two services. So this on this hand side, where in on-prem and Kafka cluster, we don't have any design choices that we can pick up. We have to work with those services. And then in right-hand side are the services that we chose, right? So we decided to build this solution on top of Dataflow as a streaming engine that reads the Kafka topic, and then BigQuery was our data warehouse. On top of it, we use Dataflex and Analytics Hub as data governance layer. And underneath all of these, the common infrastructure was logging, monitoring, and alerting. So from the on-prem different sources, the Qlik replicate will read the CDC changes, and then it will push that change to the input topic. Between the database and the Kafka topic, the mapping between those were at a data domain level or schema level. There were two granularity, right? How many topic do you want to create was basically governed by two facts. You can either do it at a data domain level. If you have a small domain, let's say HR is a domain, there might be 5 or 6 schema in that domain. All of those messages can go to a single topic, or you can say like, for my database, its single schema is one topic. Those are the two granularity that we provided here. So if you have HR domain, all the messages on HR domain can go into the input topic. Dataflow will read those input topics and then basically runs a bunch of data validation or schema validation, some transformation, and then finally put that data into the BigQuery. There are views created on top of that BigQuery so that the downstream consumer can use it. Also, the owner of that data domain or schema are responsible for making sure that they have proper catalogs, they have a proper entry in Analytics Hub so that it can be shared with different users. This was our basic architecture. The small icon with a person here represents the service account that is used to run the data flow. Again, the granularity was at a data domain level and schema level, so each data flow like pipeline, if it has a data domain layer, it has a capability to read all the input topic for that particular domain and then write to the corresponding tables in BigQuery, right? In the diagram we're trying to show here, the transformation and the data warehouse can be multiple projects. This is a common pattern. The data governance is one project and logging and monitoring is one project, but transformation, there can be a number of projects. Similarly, data warehouse, there can be a number of projects, right? So if you really have data where you want more controls, data domain where you want more control and more access only to run that particular domain, then you spin up your own transformation and data warehouse project and run your data flow in transformation project, and then your BigQuery rises in that data warehouse layer, right? Why we wanted to provide that flexibility is that there are really some domain where you want more granular control. So to flow the data in this particular architecture, the most important step was collaboration and prepping for it, right? This was the really most crucial and important step where the team from data governance, data privacy, data owner, and data stewards, all they come together and they basically define what your policy tags looks like. If there is any row level security access control that has to be defined, they might come up with business tag templates so that you have better data observability, right? So this takes more time during the data movement. We extract, there might be already some available tool like SQL translation service that basically once you say like, hey, this is my DDL in DB2, I want to convert it to BigQuery, there might be some tool that will help you to automatically start translate that DDLs, but our aim here was just to run that type of tool, get all the schema from the source, and then we might have to append some extra columns, right, on top of it. For example, sequence number or replicate timestamp that helps us to give more information about that piece of data. Right. Once this step is done, you are basically now ready for ingesting the data. You already have defined your BigQuery schema. You already have tagged it, and then you have already read code either in Terraform or Pulumi, so that you can now create the corresponding artifacts in BigQuery, and then you can start ingesting the data. At this phase, the Qlik is sending the data into the input topic. The data flow does a couple of things here. Data flow goes and once it reads the message, it does a data validation to make sure that we got the data properly. Schema validation is nothing but what we are trying to do is like we are trying to see the payload. What are the fields in the payload? Does it comply with what we have in BigQuery, right? So BigQuery might have some required fields. We are making sure that the required fields are there. If there is any other thing that has to be mapped between the payload and the BigQuery, that mapping is done on schema validation. There might be custom transformation, so we allow users to write their user-defined functions, and then they can put that in a GCS bucket. The pipeline will pick that and run those transformations. So this is not really into the whole pipeline is written in Java, so you don't have to really modify your Java pipeline. If you have something, a unique transformation that is related to one particular table or one particular data domain, you can write that in that particular JavaScript file, and then when you run it, it will pick up and then run it. Dataflow will route, so there can be different errors when we run this kind of pipelines, right? The errors can be recoverable, and it's difficult to recover from those kind of errors. So, for example, if I cannot even serialize the data I got from a payload, it's difficult to recover from that kind of error. So both recoverable and non-recoverable, we pass that errors to a Kafka dead letter topic, and we'll deal with it later. This is our general Dataflow pipeline that we run. So from the Qlik side, when we run the Qlik, the input topic, the message comes in this particular format. This basically has 3 segments: data, before data, and headers. So in first iteration, what we did was we configured the Qlik so that it will send my column names along with a REPL and the format of the data, right? If I'm getting an int, then my column name is ID and it is of type int, then my JSON structure will say like ID underscore REPL underscore int. So that gives me an idea whatever is on that after REPL is my data type. That was the first iteration that we did. And this was what used to do the data validation between what is present in BigQuery and also used to cast that value in a proper data type. We are not only doing that, we are also using BigQuery API to read the BigQuery table and then get all those table names, so that we want to make sure that whatever is in BigQuery is available in payload. Payload doesn't have extra attribute. We want to make that one also clear, right? So because we are already reading that from a BigQuery, we thought that the first having that REPL, appending that REPL on the end is not really meaningful. Instead of just reading the name of the column, why not we read all the information regarding schema and then use that, right? So in the second iteration, we drop that REPL part from the Qlik replicate. We just use the column name, and in our side input up here, instead of just reading the column name, we started reading both the column name, what is the type, and whether it is required or not, right? That gives us enough information to do any kind of data validation to make sure that the input we get is actually meaningful, and when we started writing to BigQuery, nothing fails. So these are the 2 iterations we did from the Qlik side of the thing. So once, again, error handling is done by one mechanism, right? So we said like there are 2 kinds of error: the error that can be recovered, and that's not really difficult to recover, right? So our approach here was if a pipeline has an error, it will basically have a log-based metric, and then somebody gets notified, alerted, saying that, okay, this particular pipeline has an error, and then that person will come and go through the logs and see what are the errors, what errors he has. If it is a table not found or a column mismatch, basically the solution for that is not to change the Beam code, but to change your BigQuery, right? So then he goes, write a Terraform, add new column or create a table, run that pipeline, deploy the pipeline, and then once that is done, they can hit the replay pipeline. We didn't allow the Beam pipeline itself to go and create the table or column. We can do that as well, but we didn't allow that because one of our guiding principle was we want to use infrastructure as a code, right? We want to make sure that whatever we run and build it is available there, and then that is repeatable. If somebody wants to take this and run it, they should be able to do that, right? So we didn't want the Beam to do that. That is the error. Fix your data warehousing side of thing, and then just replay the pipeline. And if the same message is seen twice, means it still has some error. At that point, playing a ping pong between dead letter topic and input topic really doesn't make sense. In those cases, what we do is we route those messages to a letter table, BigQuery table that is internal to data engineering team, so that they can go and see what that error is. We put everything together as a blob in one of the columns so that they can go and inspect it, and then based on that, they can now form like there might be this kind of data, and then go modify the data or take a proper action. So this was our error handling approach. So that helped us to build that pipeline and ingest CDC streaming. Some observation and optimization that we did was we found that having auto sorting enabled in BigQuery IO really helped us to improve the performance. Also, we encourage to have multiple environments with a similar structure. In our case, we had like tape, test, prod, and then running this prod profiling for your data flow helps you to leverage like what are the bottlenecks, identify some of the bottlenecks. Some of the things that we found was we're not properly using do function lifecycle. External APIs or external calls were handled in a do function. So we were able to refactor that to make it more sense. Another important thing is it doesn't matter how many workers do you give, the number of partitions in Kafka topic really helps you to scale things, right? So make sure that if you are running a pipeline where you are reading from Kafka, there's a proper number of partitions that for a topic is given. So that was another thing. Few of the pipelines, we increased the number of partitions, and then the performance started increasing. Similarly, Kafka customer configuration, for example, unbounded reader max read timeout in seconds. If you lower that, it will lower the latency as well. If your pipeline is doing aggregation, make sure you use another configuration, unbounded read max elements, right? Use higher number if you are using aggregation in your pipeline. Our pipeline was really straightforward. We didn't use the second one, but we did make the use of the first one. Developers has like intention to write a lot of logs. Sometimes you want to make sure that when you are deploying the same code in production, you make sure you are not doing excessive logging. So runtime configuration like default log label, defining those, passing those default log worker level config, and then worker log level overrides help you to omit that log. It won't be logged in GCP logging, so you won't see verbose logs there. Another thing that we wanted to make sure was we wanted to run these different data flow pipelines based on different schemas or data domains, but we want to have less variability between them. So we came up with using one worker type, and then we stick with that worker type for most of the pipeline. And generally, if you have a similar kind of data, it makes sense, unless you have a table that basically deals with a large amount of XML blob, then you might need to go and revisit that decision. But most of the cases, that decision worked fine for us. We also wanted to cap out the maximum number of worker, and our strategy to do that was we basically ran few experiments, and we found that we found there's a relation, like the relationship for our workload that worked was if the Kafka topic has one partition, more or less like 3 workers in Dataflow is sufficient, right? So basically, if you have a topic with 6 partitions, then max number of worker can be 88. That really worked fine for us. So in this particular example, when we're creating views, we're putting the data in BigQuery, and on the base table, we're writing SQL to create a view for that transactional database, right? I think in the future, we want to explore if we can use BigQuery CDC so that it already like compares and makes that table more transactional. So that's a future optimization that we want to do in this pipeline. This was my talk. It is about using Qlik and Kafka, and then getting that message and moving it all the way to BigQuery. And then how do you make this more efficient as you start deploying more schemas or more data domains? So you build once and you run all the times with different sources. Thank you very much.